You're listening to Let's Talk Creation, the science podcast that's just for you, with Paul Garner and Todd Wood.
Well, hello and welcome back to another episode of Let's Talk Creation with Paul and Todd. I am Todd Wood.
And I'm Paul Garner.
And we're here to talk about creation, evolution, origins, science, faith, the Bible, Genesis, theology, all those wonderful topics. We're going to have a conversation today, especially about transitional forms and the missing link. So that should be fun. Hey, Paul, we got some great feedback I thought I would share with you here.
Yeah, we've had some great feedback. We love to hear from our listeners.
Yeah, so all of you listening out there, send us your thoughts on how we're doing. Give us some suggestions on what you'd like to hear. We'd love to hear that. Here's a great email that we got recently. Thank you both for your excellent podcast. Well, you're welcome. And for all the work you do for Christ. In my humble opinion, you guys represent the best of young age creationism. Well, I don't know if we're the best, but sure, thanks. And you've both been a great help in my faith journey. I am a young Christian who was raised as a theistic evolutionist, but am now a creationist thanks in large part to your work. I have to say it has felt like a conversion experience to really, for the first time in my life, trust the scriptures from the beginning to the end. Wow, well, thank you so much for writing. We appreciate your comments. That's very kind. We also got some questions about why we're afraid of comments on our YouTube page, which I thought was funny.
Well, I guess what I found most frustrating about it was that so many of the comments are made by people who basically make no effort to actually find out what the existing literature already says. So they're kind of making objections that we've already dealt with, and it's there in the literature. And it becomes a bit sort of tiresome to deal with a lot of that, and very time consuming. It's just very difficult even to moderate it all and make sure that the good stuff that does come in gets filtered out from a lot of the noise.
Yeah, and even
so in the end, I kind of gave up with that.
Yeah, and even sometimes the good stuff that comes in is sort of a veiled attempt at, raising these old ideas that are kind of outdated, and we've addressed that millions of times. The whole notion of being able to comment on the internet just strikes me as really defective. I find myself oftentimes, if I see a provocative headline, I just skip down to the comments. I don't even read the article. I just want to see what people are arguing about in the comments. And why? What is the point? It just strikes me as unhelpful, right? So, Are we afraid of you? Sure, we're terrified. I'm shaking in my boots. No, I'm not afraid of you. If you want to make comments and have your objections, you are certainly welcome to send us an email. And I think that the act of having to sort of remember what our email address is and then write an email, that sort of filters out a lot of this knee-jerk showmanship that is the comment section of the internet. So
I'm all for informed critique.
Yeah.
I wish that the kinds of critiques that we received as creationists were the kinds that really made us think, that were thought-provoking and that kind of raised the bar. But generally speaking, that's not what comes in.
No. It's the kind that says, you guys are afraid of commentary, and so you hide the comments.
Right.
Yeah. Okay.
Yeah.
Whatever you think, sport. All right. Anyway. Well, today, as I said, we're going to talk about transitional forms. The missing link, and so forth. And we're going to do it generally speaking. I know that everybody out there wants to know about cavemen and monkey people and all that sort of business. If you're interested in that subject, I've got an episode of Ask a Creationist that we've just posted that is all about those weird monkey human embryos. So if you're thinking, what is that? What even is that? Why would anyone do that? I try to answer those kinds of questions in that episode, so check that out. But yeah, this is mostly about fossils, although there are some living things that are kind of missing links as well. We should definitely mention that. But first, Paul, why don't we just... the idea of a missing link or the idea of a transitional form just sort of says, hey, it's about evolution. Do we have some kind of definition of what we're talking about here? What is this transitional form?
Okay, so a transitional form in evolutionary theory is an organism, or perhaps a group of organisms, that developed during the transformation of an ancestral organism or group into a descendant organism or group. So it is the kind of organism that you'd expect to see if one major group had given rise to another major group.
So when you say major group, you're not talking like a Doberman Pinscher versus a Dachshund versus a Poodle, right? You're talking birds and reptiles and mammals and big things like that.
Yeah, I mean, we can think about transitional forms at different taxonomic levels.
Okay.
But generally speaking, when people use this kind of terminology, they're thinking about reptiles giving rise to birds, or reptiles giving rise to mammals, or fishes evolving into tetrapods.
Okay. So this is like...
kind of thing.
And I guess that would be kind of a big deal if you're an evolutionist looking for these kinds of evidences of these evolutionary transitions, that if you find a fish with 4 legs, or if you find a dinosaur with feathers, that would be, or a whale with hind legs even, that would be kind of a big deal to you, because that sort of fits into your idea of how evolution must have taken place.
Yeah. And I think it's fair to say that from an evolutionary perspective, it's a good argument, because evolutionary theory predicts the existence of transitional forms between major groups in a way that the creationist model does not. And so you can understand why evolutionists take encouragement from fossils that they interpret as transitional forms between these groups.
So, yeah, I think you're right. I would want to say that there's the evolution predicts the existence of these things in a way that perhaps creationists haven't fully anticipated. My own reading of history, and I've done a lot of reading on this subject because it's fascinating. These sorts of creatures existed before Darwin came along and gave them meaning, right? We knew about like the forms and the transitions between the forms, and sort of 17th century, 18th century, people were thinking, mostly 17th century, people were thinking in terms of what they called the great scale of nature, right? The great chain of being. And in this great chain of being, you'd have that basically God created every possible form that could exist. If you could imagine a form existing, then God made that form. So when the chimpanzee was first described at the end of I guess it was the 17th century, it was praised as being a link in that chain, right? So the concept of the missing link is actually kind of a holdover from this notion of the chain. But then when Darwin came along and said, well, it's not a chain, it's a family tree, suddenly people started saying, oh, no, there are no transitional forms. So, so prior to Darwin, when people didn't think about evolution a lot, they interpreted these forms, these creatures, as being part of God's creation and part of God's plan for creation. And then along comes Darwin and says they're evolutionary, and people suddenly say, no, they don't exist at all.
Yeah.
So it's kind of a funny history there. And I think that you're right in the sense that the sort of modern creationist world, I think, still hasn't sort of recovered a notion of what is this pattern. If it's not like a chain or this perfect scale that's perfectly full, then what exactly is it? So, yeah, there is a certain sense in which, in the evolutionary perspective, if you think that birds evolved from reptiles and reptiles evolved from fish, that you have to that these transitional things must have existed at some point.
I think it also, it comes back to what our perceptions are of the world before the flood, the world as God originally made it. Because today we're looking at a world that is impoverished in terms of its diversity,
right,
compared to the world that God originally made, because there's this thing called extinction,
yes,
right? And we had an event called the flood, that has led to the extinction of entire communities of organisms. And so the world that we look at today, which has these what appear to be very big divisions between these groups, like reptiles and mammals, they're pretty clearly defined today, or reptiles and birds. Birds alone today possess feathers,
right.
But we can't assume that the world that we're looking at today is representative of the world as God originally made it.
Yes.
And I think there are good reasons to believe that that there was all kind of diversity in that original world that doesn't exist today. So things that had feathers that were not birds, and tetrapods that had some features that today maybe we only find in fishes. And God loves diversity. He loves beauty. He filled this world with an abundance of different organisms, and today we've lost a lot of that diversity, and so it actually makes some of those distinctions between those major groups look bigger than perhaps they would have looked if we were looking at the world before the flood.
Yeah. So just to clarify for our listeners, what is a tetrapod?
Yeah, so a tetrapod is basically an animal that has limbs with digits, as opposed to a fish that has fins.
Okay.
So it has 4 limbs with digits.
Am I a tetrapod?
Yes, you are a tetrapod.
Interesting.
Because you have limbs with digits.
With digits. And I thankfully I still have all my digits. So
you do.
I can count. All right. Well, that's good. So you say that this transitional form, you said, was something that is interpreted to be this sort of representative of an evolutionary transition, an evolutionary change from one big group to another. I think the preferred terminology nowadays is stem taxa. Right, where if you think of an evolutionary tree and you have what we would think of as a crown group, which would be the existing creatures, sort of the more advanced forms, the more typical forms of a group, then on the base of the tree, if my hand is the tree here, down here on the stem, the trunk of the tree, there would be these little shoots coming out that would represent the transition. That's right. Where the terminology comes from, stem taxa. And I think people want to get away from, I think evolutionary biologists are sort of pushing away from the idea of transitional form, because we can never really be sure, and this is just going to be generally true, we can never really be sure that any given taxon is the transition, right? We don't have that kind of knowledge, and we don't have really the ability, even if we had sort of perfect data and perfect representatives of all the fossils, it would not be possible to pick out which ones were the actual ancestors. So they're sort of trying to push away from that. And I think they're trying to push away from the idea of the missing link, that there's something missing here and they have to find it. Mm-hmm. They've been finding this stuff for centuries. So,
yeah.
But if I'm a creationist, right, which I am, and I don't think there was ever an evolutionary transition between birds and reptiles. If I open my Bible and I see on the 5th day of creation, God made flying things and swimming things. And then on the 6th day of creation, he made creeping things and beasts of the field and human beings. So that by the end of creation week, basically all the major vertebrate groups are already present, right? There are already fish, there are already reptiles, there are already mammals and birds. Well, how do I even, what is a transitional form to me? I mean, it's not evolution, right? So what, and yet these things, they exist, right? So how do we talk about this? How do we as creationists talk about this?
Yeah, well, this is a very good point, because the point that you're making is that the very term transitional form is itself a loaded term.
Yeah, we kind of give away the store already, right?
Exactly. I mean, we've conceded the argument when we call these things transitional forms, because that term really only has meaning within an evolutionary context.
Right.
So, is there another way that we can talk about these things? Kurt Wise published a very interesting little article. It was just a short article in the technical journal, what's now Journal of Creation, some years ago, which we will link to in the show notes because it's a very helpful piece. And in that paper, he proposes different terminology. So he suggests that we don't call these things transitional forms, but instead we call them stratomorphic intermediates. Now that sounds a bit of a mouthful.
That does.
And I'm sure people are saying, what on earth is a stratomorphic intermediate? Well, let me try and explain. So the term stratomorphic combines two other terms. So we have the concept of a stratigraphic intermediate, first of all. Now, a stratigraphic intermediate simply means any fossil which is found between two other fossils in the series of rock layers. So if you think about the stack of rock layers, the oldest at the bottom, the youngest at the top, rather like we talked about in our episodes on the geologic
column. Yeah, I was just going to say that. People should go back and listen to those if they're not clear on what we're about to say here. So continue.
Yeah. So you have a series of rock layers, you have fossils in those rock layers, and any fossil that is in an intermediate position between two other fossils in the rock layers is a stratigraphic intermediate. So that's pretty simple. And then we have this other concept that is a morphological intermediate. Now here we're talking about the morphology, or the shape, the appearance, the body form of the fossil itself. And a morphological intermediate would be a fossil organism that has a body form, a morphology intermediate between two other organisms. So, you can think perhaps of morphological intermediates even in the modern world.
Yeah, I was going to say it's not necessarily fossil, right?
Yeah, not necessarily a fossil. Yeah. So think about the platypus.
Right.
It's a kind of morphological intermediate because it has some characteristics that it shares with other mammals, but it also lays eggs.
Yeah.
Which, most mammals don't lay eggs. That seems to be something that you'd associate with reptiles.
Right.
So it's a morphological intermediate. So a stratomorphic intermediate is basically a fossil which is both a stratigraphic intermediate and a morphological intermediate. So, in other words, it lies in the rock layers between two other organisms, and it is also a morphological intermediate between those two organisms. And it's these stratomorphic intermediates that very often are being interpreted by evolutionary scientists as evolutionary transitional forms. But that is an interpretation of the fossil.
Right.
Okay. When we talk about them as stratomorphic intermediates, that's descriptive terminology. We are simply describing what we see in the fossils and in the rock layers.
Right. Right.
When we call them transitional forms, we've taken a further leap. We've now interpreted this stratomorphic intermediate in an evolutionary sense. And I think it's just good practice for us as creationists to take a step back and say, well, look, let's not leap to an interpretation. Let's just describe what we see first of all.
Yeah.
And then we can start to try and work out what it actually all means.
And I think that's generally good advice for science. Mm-hmm. Try not to use this kind of loaded terminology that sort of jumps to, well, this is what it must be.
Yeah.
People who jump to those kinds of conclusions usually end up regretting it anyway. So I thought maybe we could help our listeners, and unfortunately this is going to be visual for you people listening, but I have here in my office a stratomorphic intermediate, and perhaps we could talk through its characteristics. You've been listening to Todd and Paul Talk Creation. If you'd like more information about any of the subjects discussed in the show, please visit us at coresci.org/podcast. That's coresci.org/podcast. If you'd like more information on sponsorship opportunities, or maybe you'd like to have a product or book reviewed or discussed on our podcast, please contact us at podcast@coresci.org. That's podcast@coresci.org.
Do you have questions regarding the young age creation as a model? Well, we've got you covered with a book by podcast's own Paul Garner. His book, The New Creationism, was dubbed the single best book on creation and the flood by filmmakers of Is Genesis History. If you don't already have a copy, be sure to check it out on Amazon today. Now, let's get back to the podcast.
Well, that looks like Archaeopteryx lithographica.
Yes, that is exactly what it is. Now, it is...
Yeah.
Just to be clear, this is a resin copy. I don't actually have the original fossil here. This particular... Where's
Wouldn't
this
that be
particular
nice?
fossil located?
It was found in the Solnhofen limestones in Germany. They're Jurassic limestones, so if you want to think about a conventional geological age, that's about 150 million years.
Okay.
They are a series of finely laminated limestones in that region of Germany. Lots of well-preserved fossils in them, including this spectacular creature here, Archaeopteryx, that was first discovered there.
Now, there are more than just this specimen, right? There's half a dozen of them by now?
Yeah, so maybe a few more. So,
yeah, less than half a dozen. So there's very few of these guys. So let's see if we can point out some things. First of all, I think the most prominent thing are these big wing feathers here. That kind of makes it a bird in my book, I guess. If you've got big feathered wings.
And they're asymmetrical feathers, quite like the feathers of modern birds.
That's right. And then there's all the tail feathers down here. Asymmetric feathers. He's probably using them to fly, or that would be consistent with modern asymmetric wing feathers. They're used in flying. So that suggests that this guy flew, although I think the jury is sort of still out and people are still debating whether the mechanics would work. But anyway. But he's got some very peculiar features here. One of those features, right here, this is his wing, right? There's his arm and his wing. And now on a normal bird, the hand bones are basically all fused together, right? Into sort of a pointy thing that basically serves as attachment for the feathers.
Yeah.
Look at this.
Yeah.
He's got individual fingers.
Yeah.
And the fingers terminate in claws.
Yeah. Now that's something that you don't see in modern birds. There are There are modern birds, I think, that have juveniles that have little wing claws, like the huatzin in South America.
Right.
But most birds don't have those wing claws, even in the juveniles.
Right. Right. If we look a little bit further down here, something missing from this guy. And, well, a couple of things that would be missing from this guy. You know them from carving chickens or turkeys that you've cooked. There's this, well, we call it a keeled sternum, right? So the sternum being the bone here right in the middle of the chest that connects the ribs together from either side of your chest. And in birds, there's this keel. It's basically got one piece that goes this way, right? And then there's another piece that sticks straight out like this. And that keel serves as attachment for the flight muscles. So the keel is really important. And you'll notice here, this guy doesn't have one. Doesn't have a wishbone either, for that matter. Which is a modified collarbone in birds. Now, lacking characteristics, that could always mean that it just didn't get preserved. But in this case, the preservation is so spectacular, it's really hard to imagine that if it had a keeled sternum, it sort of fell off, and especially when it's attached to all the ribs. So we could be a little more confident here that this thing never really had one to begin with, which, again, is a very unusual bird characteristic. And then the last feature here, this... We look down here, we can see the legs of the bird, right? And then we see this long bony tail. And in modern birds, tails are basically just these little stumpy things that don't really have very many vertebrae in them. So this guy has this long bony tail, which is unheard of today. And one more feature here that's really hard to see. What's in its mouth?
There are teeth.
Oh.
And there are no modern birds that have true teeth.
Right.
Like that.
Yeah, so it's Jurassic, right? You mentioned that. Mm-hmm. And this guy has been interpreted. The features that we just pointed out as being intermediate would be features that you would find in things like dinosaurs of the day, right? Well, maybe not dinosaurs of that day. But, I suppose. Bony tails and claws on the hands and teeth in the mouth. Those would all be features that would be common to dinosaurs or reptiles living at that period.
It has a lot of features in common with a little theropod dinosaur like a dromaeosaur.
Right.
Yeah.
And there are those who would argue that it's actually not a bird, but is in fact a dinosaur, because it has so many of those characteristics that it shares with the dinosaurs.
In fact, when evolutionary scientists do phylogenetic analyses with, when they're building evolutionary trees with Archaeopteryx in them, Archaeopteryx sort of bounces around a little bit, and sometimes it seems to cluster, on the bird side, and sometimes it sort of seems to be a dinosaur.
Sometimes it shows up on the dinosaur side, yeah.
Yeah, it just bounces around a bit. Yeah.
So even sort of the evolutionary paleontologists and so forth don't have a firm idea of where this guy goes, other than he must be a stem taxon, right? He must be a transitional form. Archaeopteryx is intermediate because it shares characteristics with things that are not birds, and yet it clearly has features that for centuries people have just assumed that Archaeopteryx is a bird, which then sort of makes it the classical intermediate form.
Yeah.
Now,
and since the 1990s, we should mention that in China, a whole series of fossil discoveries have been made of what are clearly types of dinosaurs, but which have feathery type coverings. Some of them have a kind of fuzzy filament-like covering that appear to have some resemblance to feathers in the sense that they're hollow and they're pigmented.
Mm-hmm.
So they're not just frayed collagen fibers or products of decay. They appear to have some structure that resembles feathers. And then others have what clearly are feathers with, the branching structure of feathers.
My favorite is Microraptor.
Sure. And these are Microraptor's a little four-winged creature. I mean, it's very different to a modern bird because it has, in effect, four wings because its hind limbs also are feathered and form a kind of aerofoil structure.
the kind that you would see as a flight feather on a bird's wing. So it's got basically four wings. It's pretty funky looking. Okay, so that's what we mean when we talk about these intermediate forms. And the evolutionary biologist is very excited about these things, sometimes, because they fulfill what they expect to see as a transition between one group and another. Although I must, just for historical sake, Archaeopteryx was originally named by Richard Owen, who was something of a skeptic of Darwin's, and he named it after his own understanding of sort of the pattern God used to create things called the archetype. Actually, that's his diagram on my wall right there. This is Owen's diagram of the archetype, and he called Archaeopteryx because he felt like it was the bird that was closest in appearance to the original archetype. And T.H. Huxley, who's Darwin's bulldog, right? The big promoter of Darwin in England at the time. He was somewhat skeptical of using Archaeopteryx at first because he thought that birds must have evolved at a different time period than the Jurassic. And so he really didn't get all that excited about Archaeopteryx as a transitional form, which I think is weird. And it was only later on that scientists began saying, well, Archaeopteryx is obviously a transitional form between birds and non-birds. But that's neither here nor there. That's more the politics of the day. I sense that Huxley hated Owen passionately, and I don't think Owen much cared for Huxley either. So I think there was a lot of personal animosity in the way they handled those things. If Owen named it and likes it, then it can't possibly be good for evolution and that sort of thing. So anyway, but that's usually not what happens today. Usually what happens today is when there's a new intermediate form, as you've mentioned, all these weird feathered dinosaurs that have been discovered in the past 20, 30 years. People have been very excited to promote them and celebrate them as missing links, as transitional, evolutionary transitions. Look at what we found. More and more evidence of evolution. So we have words, right? We have words for these things, the intermediates and the morphological intermediates. So a morphological intermediate would be a platypus, and then a stratomorphic intermediate might be Archaeopteryx. But what are they? And I've sort of briefly alluded to the Great Chain of Being. We don't think that's right anymore, right? I mean, things are more complicated than a line. So what resources do we have as a creationist for explaining and sort of trying to understand what these things are? Because so far this podcast has been mostly about look at what evolution has done, which that's a depressing thing to talk about. So any thoughts in that regard? Yeah,
sure. Well, from a biblical perspective, of course, we think that these are not evolutionary transitions because, as you alluded to earlier, the Bible talks about flying things being created separately from from land animals.
Right.
They're created on separate days. So we don't think that dinosaurs gave rise to birds in an evolutionary sense. They must represent different created groups. So the question is, do we have something in our toolkit that can help us to investigate that?
Right.
And one of the things that we can do is we can apply the techniques of baraminology. Baraminology is the study of the created kinds, and we have a whole set of methods, including some statistical methods, that allow us to analyze fossils and determine whether they belong to the same kind or to different kinds. And Todd, you and I and others have done some work specifically on these feathered dinosaurs. And what did we find?
Well, bunch of things. But I think the most significant thing was that with the methods that we've used over the past 20 years, birds, what we think of as birds, and even weird fossil birds, and dinosaurs and different groups of dinosaurs sort of fall into separate categories that would, in my opinion, agree with the idea of separate creation. So on the one hand, you have, and this, you can think of this as sort of testing what evolution says, right? So evolution tells us there must have been an evolutionary progression here, and there must have been a transition between dinosaurs and birds, and then these feathered dinosaurs are the stem taxa that represent that transition. Yeah. And
so if that's true, we'd expect continuity, right?
We'd
expect a kind of continuous
yeah.
morphological series.
Yes.
We wouldn't expect to find discontinuities between these different things.
Right. And so the question then becomes, is that true? Is there a continuous transition where you can see each form as it goes, or are there groups of things? And it turns out, yeah, there seem to be separate groups, which I think is really interesting. So, and it certainly raises the question of what does it mean? But at the same time, it tells me it's not just a slam dunk for the evolutionary prediction that there is this unbroken transition. And I suppose the evolutionary biologist might say, oh, you're just splitting hairs, blah, blah, blah. That could be true. I don't think so. Splitting feathers, maybe, but not splitting hairs. But what I think what's really interesting about this, that I think baraminology can really sort of help us with, is the feathered guys. So thinking here about Microraptor and the sorts of things that are in that sort of group that the paleontologists are putting forward as being the most likely evolutionary stem taxa to modern birds, those seem to form their own created kind. Possibly two created kinds there, but at least one. So the feathered, the dromaeosaurs, the velociraptors, the microraptors, all those sorts of things that are these feathered dinosaurs, sort of classical feathered dinosaurs, they seem to be one created kind, which I think is really interesting, because then that suggests that some of their features that appear to be transitional, right? So some have more feathers than others, some have better developed feathers than others. Those are all within a created kind, which suggests to me that we're looking at just the variety of organisms within a created kind. God created the ancestors of these dinosaurs. They diversified before the flood. When the flood came along and buried them, which is how we would understand the origin of these fossils, then we get this snapshot of diversity that was all living at the same time. And that is representative of a variety of forms of the same basic critter, the same created kind. So I think that's an important an important thing for us to think about as creationists, that we're not always bound to think of these transitional fossils as being, separate, different from the forms that they're supposed to be the intermediates between and so forth. That in fact, they might be their own created kind, showing their own diversity. I think there's another group that's pretty famous that we've played around with again. And maybe you could tell us about fossil horses.
Yeah. So fossil horses are very interesting because, for reasons we'll find out, they're actually quite a different. I was going to say a different kettle of fish, but we can't call horses a kettle of fish.
No,
can we?
That would be evolution. They're more of a kettle of horses, really.
But So the results that we get when we play around with the horses are very different from what we get when we look at the feathered dinosaurs. So let's think about the horses. So today, if we think about modern types of horses, there's some variety, but they're very similar.
Yeah.
They have the single hoof, the single toe, and they have the same kind of teeth, broadly speaking. And yeah.
But if you see a zebra or a donkey or a horse, it's unmistakable, right? They basically just look like they've put different pajamas on, and now there's some other, but they're not fooling me. I can see that you're still a horse.
Yeah, exactly. But that's not the case when we look at the fossil record, because when we look at the fossil record, we find that there are many species, I think about 150 species of fossil horses, most of them extinct today. And there is a huge amount of diversity among these fossil horses. So the oldest members of the horse group that we find in the record, or at least what we think are horses, are small animals. They're kind of about the size of a fox terrier, and they have 4 toes on the forefoot, not a single hoof. They have browsing teeth, not grazing teeth, high-crowned grazing teeth like modern horses. They have low-crowned browsing teeth. So these are very different kinds of animals from the modern horse. And then we have a whole bush, if you like, a whole series of fossils we find them through the sediments that are dated in conventional evolutionary terms to represent the last kind of 50 million years or so. And although it's very messy, we can discern some overall trends. So we see kind of an increase in body size. Yep. We see animals at the base of this sort of bush that have browsing teeth, and then we have the development of grazing teeth, the appearance of grazing teeth. We have the reduction and loss of side toes, leading to the development of the single hoof. And we find a whole series of kind of transitional forms, if you like, that sort of seem to show these morphological trends. We even have populations of fossil horses where some of the individuals in the population have 3 toes and some have 1 toe, all in the same, what appears to be the same species, interbreeding population. So, this is a classic evolutionary series. And you often see it depicted in museum displays or in textbooks. It's usually portrayed in this very sort of linear way where you have little Hyracotherium at the beginning and Mesohippus in the middle, and you've got Pliohippus and Equus at the modern horse at the end. But actually, that's a huge simplification of what's actually a very complex fossil record. But nevertheless, there are these sort of broad trends that you can discern in the fossil record of horses. And this is again is portrayed as a classic evolutionary case study, right? So this is, Hyracotherium is ancestral to all of these subsequent horses, including the modern day horse.
Right. So
what do we make of this?
Yeah.
This is a really interesting example And we've again applied, haven't we, baraminology techniques to the fossil horses. And what did we find in this particular case?
It surprised me. I did not find horses sorting out into these easily identified groups. They look as if they're all members of the same group.
One group, the same kind.
Yeah.
Yeah.
Now, I should say, we haven't studied those to the same extent that we studied the feathered dinosaurs. We could change our minds, but given what we've done already, they look to be all one single group. And honestly, it doesn't really bother me that much, because really, you start out as a horse and you end as a horse, and you've got horses all in between. There's this diversity of form that we see in the series, for sure, with the toes and the teeth, the form of their teeth, and so forth. And the size, for sure. But it's not like a gigantic, mammal-like reptile or, fish with legs or something like that. It seems to be a much more sort of tame and kind of boring transition. As far as...
And they all seem to be classified as members of a single biological family.
Yes, right.
Which is not like what we find with the feathered things, because we've got multiple different families there. We've got dromaeosaurs, but they're a different family to the Microraptors, and those are different from some of the modern birds. So there we're dealing with multiple families, but here with the horses, these are all members of one family.
Right. And so it seems to me the easiest thing for interpreting the horse intermediates is that, I'm not sure that we have to interpret them as sort of evolutionary transitions, but we could certainly say that they represent the diversity of form within a single created kind.
And it kind of makes sense, because these fossil horses are found in sediments that, as creationists, we think are post-flood sediments, right?
Yes.
Assuming that we've identified the location of the post-flood boundary correctly, they appear to be post-flood. And one of the things that we know happened after the flood is that there was a period of some centuries of recovery, where there was residual catastrophism going on. The Earth's climate was changing. It was drying out over time, and it was cooling down. And the trends that we see in the fossil record of horses make sense in that context, because we have an overall size increase, which is something that we typically think is probably connected to a cooling climate, because larger animals are better able to retain their internal body heat than small animals. The reduction of side toes to a single hoof kind of makes sense if the world is drying out and the grasslands are spreading and the ground is becoming harder. It's a more efficient design for running on those kinds of surfaces. The change from browsing teeth to grazing teeth makes sense, because we see in the plant record in those rocks, we see a change from more forested environments to more grassland environments. And so we see this switch from sort of teeth that are suitable for browsing on foliage to teeth which are good for chewing hard grasses with lots of silica in them. So the changes that we see in the horses sort of make sense, don't they, in a post-flood context?
So yes, I think those trends in the fossil record there really do make sense from sort of a creationist flood recovery perspective, and the way that we see the changes happening in the horses. Yeah, Yeah, that fits exactly what I would expect the post-flood world to be like, as things are sort of recovering. The earth is, regrowing stuff. So you mentioned
And
several
it's not
times.
just the horses. It's not just the horses either, is it? I
Exactly.
mean, this is interesting because we see similar trends in the fossil record of elephants and
Yeah, just
brontosaurs
about
and
everything.
other all the other mammal
Right. So you mentioned
series too.
browsing and grazing teeth. I thought it would be good for us to sort of explain what that is. So a browser, let's start with browsers. They would nibble things off of bushes, right? So it would be sort of the soft, leafy vegetation that you would grow on a bush. Whereas grass is, and maybe our listeners don't know this, but grass is a much tougher kind of a plant, and grass, the leaf itself, is basically grittier. It's got stuff in it, minerals in it that give it a tougher, grittier texture. And so if you're going to regularly eat grass, you will need a tooth that can survive that kind of wear and tear. So typically what you'll see is in a modern horse, if you've ever seen a modern horse tooth, it's extremely long. At the bottom of it, there's a tiny little root, which represents the root of the tooth, and then the top of it is the crown, right? Which is this gigantic thing, and they could just grind off the top, and it's fine. Whereas a browser would have something more like our teeth, where you have a root that's approximately the same size as the crown, not exactly, but close to it, and so the crown is very small, and it's usually pointy for cutting apart the leaves. So that's one of the things that we can tell from the fossil record, that mammals in many different groups suddenly show these high crown teeth about the same time as the first, well, not the first, but the grass fossils really begin to proliferate. So as you mentioned, things are kind of drying out after the flood. Early forests that probably grew in the heavy rains right after the flood are sort of giving way to grasslands now, which is a much more drought tolerant form of ecosystem. And so if there's only grass left to eat, the mammals have to eat it. And so what do you know? They have teeth that can do that. That transition always struck me as really odd, because it's like the mammals are sort of responding to the change in food availability. Very weird. So okay, so we've got different ways of understanding these things, these intermediate forms. We've got the idea that they represent these completely separate created kinds, that they aren't really transitions at all. And then we've got the other ones that seem to be, like within certain groups of other dinosaurs, within the groups of horses, you have these forms that appear to be just members of the same created kind. So it seems that the creationist has sort of a multiple and kind of a nuanced way of understanding this issue. It's not just a matter of these aren't really transitions. It's a matter of, well, what exactly sort of form are we talking about? So it's a bit more complicated than the evolutionary perspective, which just sees a morphological intermediate and immediately says this must be a transitional form.
Yeah.
And I would also say, we should bring this up as we close here, there are morphological intermediates that are not stratomorphic intermediates, or not very good stratomorphic intermediates. So the platypus today, right, is alive now. It is not. There are fossil platypi that do show up in the fossil record about where you would sort of expect the evolutionary transition to be, and yet we still have living platypi that are clearly not fossil forms. Now, an evolutionary biologist would simply say that's a relic stem form that has survived to the present. But if I'm thinking in terms of sort of stratomorphic intermediates, the morphological intermediate that is also a stratigraphic intermediate, well, now I have something that is not a stratomorphic intermediate. It's only a morphological intermediate, which is essentially what we have said that's what you had in the beginning. Before the flood, all of these groups that were sort of intermediate between one another, they're living in the pre-flood world together. And so you could have gone out and gone exploring and observed the various, the four-legged fish. You could have observed the feathered dinosaurs. You could have observed the mammal-like reptiles and so forth, all living together at the same time, kind of like, the platypus today. So they were essentially at the beginning all morphological intermediates, and none of them were stratigraphic intermediates. All right.
Well, I mean, there are so many questions that we haven't managed to sort of deal with in this this episode,
and we know that.
Yeah, I mean, there are all kinds of examples of stratomorphic intermediates that we haven't had time to talk about, and we haven't really talked about why do we find them buried in the rock layers in that particular sequence if they were all living together in the pre-flood world. And of course, these are all things that we could talk about on some other occasion, and no doubt we will come back to all of those questions.
This is a good...
The other thing I just thought it was worth saying, because, people do get very exercised, don't they, about the transitional forms question. And I think, it's worthwhile just saying as we kind of close out here that when we talk about the transitional form issue, we have to see it in the context of all of the things about the fossil record that the creation model explains really well.
Yes.
So, we might scratch our head about some of these transitional forms, but, when we look at the abundance of well-preserved fossils and the fact that, most groups actually appear abruptly in the fossil record, and there aren't transitional fossils linking them to other groups, and the fact that the order of appearance of higher groups in the record doesn't seem to match well with evolutionary expectations. And there are so many other aspects of the fossil record that the creation model, I think, explains better than the evolutionary model. But when we come across, what seems to us a bit of a puzzle, we need to remember that we're thinking about it in that broader context.
Yeah, it seems like a big deal because of the evolutionary predictions.
Yeah.
But it's actually a small piece of... It's just a small mystery. Certain things are small mysteries. Let's not even say that they're all small mysteries. There's a few things that are small mysteries in the larger creation and larger creation model. And I, we can refer our listeners and viewers back to our episodes on the geologic column, and the nature of the column itself is, I think, a good piece of evidence for a global deposition of the column. So
and if people want to explore what creationists have written, particularly with regards to the baraminology of these stratomorphic intermediates, I've put together a reading list. Which we will upload onto our website, and we'll link to that in the show notes, so people can go and have a look at and sort of explore the literature.
Excellent. Very, very helpful. So next week, or in a fortnight, we're going to have another episode here. And I guess we should continue this theme. We're gonna come back to these intermediate forms a lot, I think, because there's a lot of them to talk about, and I think they're fascinating, and lots of creationists are sort of working on these issues. But there's one group in particular that is particularly annoying and comes up all the time when we go to speak, and that is the ape men, right? So everybody wants to know about these cavemen, these ape men. What should we think about them? well, come back next for our next episode, and we will give some thoughts, because I've studied that issue for more than a decade now, and yeah, there's a lot to say there. Lots worthwhile saying. All right, well, thank you for joining us. I think, looking at my clock down here, I think we're out of time. So please visit us on our website. That's coresci.org/podcast. Paul Garner, if I wanted to make a contribution to Biblical Creation Trust, how would I do that?
If you go to our website, which is biblicalcreationtrust.org, there's a donate button on the homepage.
Great. And for Core Academy of Science, if you're in the U.S. and looking for a tax break, we are a nonprofit. You can go to coresci.org/donate. That's CORESCI.org. And there you'll find also links to all of our social media accounts. We're on Instagram, Twitter, and Facebook. Paul, you're there as well?
Yes, that's right.
Okay.
Yep, they can just look up Biblical Creation Trust and they'll find us.
There we go. And also the podcast, Let's Talk Creation. We're on Facebook. If you'd like to interact with us there, we would welcome that. Just look up Let's Talk Creation. And we're also on, I think, Instagram. And so thanks for listening, and we will see you soon.
See you next time.
Thanks for listening to this week's episode of Let's Talk Creation. If you have questions, send them to podcast@coresci.org. That's podcast@coresci.org. And be sure to let your friends know about Let's Talk Creation. And check us out on social media. Thank you.